Welcome to this explainer. Today we're jumping right into a totally fascinating real-world botanical experiment. We're looking at a localized case study from a gardener named Ang, who actually documented plant survival during a brutal heat wave back in June of 2026. We're going to unpack exactly what survived, what totally failed, and why understanding these little micro-experiments is absolutely crucial for weather-adaptive planting.
Let's just get right into it. On June 12th, 2026, Ang published this digital diary entry, and it completely grounds our explainer in a genuine primary source. It kicks off with a simple, "Dear Interweb." This isn't some sterile, disconnected lab report. It's literally part 923 of Ang's ongoing notes on gardening. It's raw, it's observational, and it sets this wonderfully intimate tone for the real-world data we're about to dig into together. It is a textbook example of citizen science in action. Now meet the star of our show, the hardy survivor, Blue Porterweed. Scientifically, that's stachytarpheta-cayennesis. Basically, this is a plant that's fully capable of surviving a long drought season with little or no watering at all. It really sets the stage perfectly for our microexperiment case study. We aren't just talking about a resilient plant in theory here. We're going to see exactly how this specific species performed when pushed to its absolute limits by Mother Nature herself. But hey, before we get to the results of that heat wave, there is a super fun little Easter egg for all you attentive botanists out there. Notice the tiny discrepancy in the details? In the actual text of the post, Ang calls the plant jamaicensis, but down in the digital tags, it's suddenly listed as cayennesis. It's just a fantastic, relatable reminder of the wonderfully messy, human side of keeping localized gardening notes. I mean, even the most dedicated gardeners cross their wires sometimes when categorizing these incredible plants. Okay, so let's look at the actual parameters of this environmental trial. The 2026 heat wave conditions were incredibly intense, and that was paired with a strict mandate of little or absolutely no watering. But the real kicker here? That second point. There was a shockingly high water evaporation rate happening specifically during the night. Normally, plants get a chance to recover and hold on to their moisture when the sun goes down, right? Well, not this time. This specific heat wave offered zero nighttime relief. It was quite literally the ultimate stress test. And yet, despite those incredibly harsh conditions we just talked about, this totally amazing observation emerged. The Blue Porterweed cuttings were absolutely thriving. I mean, think about that for a second. We aren't even talking about established, deeply rooted plants here. We're talking about fresh, vulnerable cuttings. Under the immense pressure of rapid nighttime evaporation and a severe drought, these cuttings somehow flourished. They completely defied all the standard expectations we have for newly propagated plants during a brutal heat wave. No way, right? So how on earth is this possible? Well, Ang narrows down this unbelievable survival rate to two localized factors, effectively transforming a simple backyard garden into a really fascinating laboratory. The hypothesized survival factors are, number one, the potting mix, and number two, the right microclimate. Ang suspects that whatever specific soil composition was used played a foundational role in retaining moisture. But honestly, it's that second factor that really dictates the outcome of this extreme weather test. And this brings us to a crucial macroscopic takeaway. Let's zoom in on that microclimate factor. Ang specifically notes that the cuttings were not placed under full sunlight. It sounds so incredibly simple, doesn't it? But planting in the right microclimate is a literal lifesaver. Just by shifting the environmental exposure, limiting direct solar radiation during an already punishing heat wave, the porterweed was able to conserve what little moisture it had against that aggressive nighttime evaporation. To truly emphasize the severity of this heat wave, just look at this stark contrast. On one hand, we have the rugged, thriving porterweed completely outperforming the delicate basil seedlings. The basil totally failed in the exact same severe weather conditions. This side-by-side comparison, this is exactly why localized garden testing is so vital. It visually proves that there's just no one-size-fits-all approach to drought survival. Plant selection and inherent resilience are absolutely everything when the heat ramps up. So how do we actually build this into an actionable formula for your own weather-adaptive gardening? Well, taking a page right out of Ang's successful microexperiment, step one is prioritizing hardy genetics. You gotta choose plants inherently capable of drought survival, like our buddy, the Blue Porterweed. Step two, use the right potting mix to maximize that water retention. And step three, carefully select your microclimate so you avoid full sun during peak heat wave seasons. Boom. It's a brilliant three-step blueprint for building climate resilience right in your own backyard. But wait, what about that failed basil?
Well, Ang actually embraces this failure as a vital learning moment. They wrote, "We'll need a different strategy and we'll grow them differently next year." And you know what? That is the very essence of adaptation. True resilience means observing the data, owning up to what didn't work under the stress test, and willingly pivoting your strategy. A garden is never really finished, is it? It's just a constant, iterative process of learning.
So we're going to wrap up this explainer with a provocative question drawn straight from Eng's final sentiment, and it challenges you to reflect on your own climate-adaptive planting practices. What is your gardening strategy for next year? When the next heat wave hits and those nighttime evaporation rates climb, are you going to be caught trying to save failing seedlings in the full baking sun? Or will you adapt your microclimates, tweak your potting mix, and lean into the hardiness of survivors like the Blue Porterweed? The climate is shifting, our gardens are the laboratories, and the next successful experiment is entirely up to you.